Hi, welcome to our discussion on hygrometry. We're working our way through different types of humidity measurements. Right now we're looking at hygrometers. We talked about the electrical hygrometers in previous videos. We're going to look at mechanical ones now, meaning that as water vapor changes, you get some change in the length or the of some property as a result of absorption or adsorption. And believe it or not, these were the first hygrometers that were invented back in the Middle Ages. They looked at how changes in water vapor resulted in dimensional changes in some material. And that was hooked up to some sort of transducer to indicate the amount of water vapor in the atmosphere. So we're going to look at early hygrometers first. And the first hygrometer was invented by Nicholas of Cusca. I think that was in Italy. He used wool and a scale. So wool absorbs water vapor from the atmosphere. The weight of the wool changes, and as a result, on a scale, it can indicate how much water vapor was absorbed by the wool. Another one, very similar, was invented by, of course, Leonardo da Vinci. Came up with, instead of wool, using a sponge to indicate the amount of water vapor that was in the atmosphere. And other inventors came up with other methods. There's Francesco Folli came up with a method whereby he used a strip of paper. And of course, the length of paper changes as a result of the absorption of water vapor, much like wood changes its dimension also. And then finally, the first hair hygrometer came about in 1783. And hair hygrometers were very popular. So we're going to look at hair hygrometers in a little bit more detail. As a matter of fact, they were used actually right up until the middle part of the 20th century. And still, you might find hair hygrometers here and there in certain places. So, hair hygrometry. The principle here is that the length of the human hair is dependent on relative humidity. As water vapor in the air increases, the length of hair changes. It actually increases also. From 0 to 100%, your hair will change by 2 1/4%, believe it or not. And it's not absorption, but adsorption, meaning that a layer of water forms on the hair follicles. So, believe it or not, wet hair, completely wet, is shorter than hair that is unsaturated. But as water vapor is adsorbed on hair follicles, the hair expands. One hair does not make a hair hygrometer. You have to have many hairs. As a matter of fact, a hair hygrometer uses a harp of hair. And as a result, they stretch that hair between two base plates, and they have some tension on it. And as the tension changes, that's hooked up to a lever, and that lever will go up and down, indicating the change in relative humidity. There is some maintenance required with hair hygrometers, and it goes beyond just dandruff and shampooing. They say that there's a low drift at low relative humidities for extended periods of time. You have to remove the dust on hair hygrometers because we talked about this in another video, that dust actually absorbs water vapor. But hairs tend to last for several years. And when you replace the hair, you have to recalibrate the instrument. Some disadvantages of hair hygrometers is that they have a very large hysteresis and they have a lag time. You have to expose it to water vapor, a certain amount of water vapor for a period of time for it to respond, so it takes some time to respond. Also, the calibration may drift and it is non-linear. Here is a graph that shows the elongation of hair with increasing relative humidity, and you can see it's not a straight line. So that's a little bit about mechanical devices, and more specifically the hair hygrometer.